Hello, welcome you all in the mechanics question papers. I hope you will enjoy these papers. I try to solve everything clearly. This is Winter 2021 variant 42 mechanics for A level. Welcome you all, mechanics. This is Cambridge International AS and A level exam. It is paper 4. This is for October November 2021. Its subject code is 9709. Its event variant 42. Its exam duration is 1 hour 15 minutes. Then always you have common question. What will be the value of g gravitational, acceleration due to gravity? 10 meter per second. And always keep the answers in 3SF, and for angle keep the answers in 1 decimal places. And always show your working clearly. And it's 50 marks papers, and marks is given in square bracket. Let us go through the question. See, the diagram shows a velocity time graph which models the motion of a car. The graphs consist of 6 straight line segments. The car accelerates from rest to the speed of 20 meters per second over a period of 5 seconds, then travels at this speed for further 20 seconds. The car then decelerates to a speed of 6 meters per second over a period of 5 seconds. The speed is maintained for the further t minus 30 seconds. The car then decelerates again to a speed of 20 meters per second over a period of 50 minus t seconds before decelerating to rest over a period of 10 seconds. During the two stages of motion, the accelerations are equal. Find the value of t. So see this one, this is the acceleration, and this is also the acceleration. This one is 5 and this is 20. So its gradient is, acceleration is 20 by 5 and 50 minus t, and this one is 20 minus 6, 20 minus 6, that is 14. So let me write 14 divided by 50 minus t. 7 to the 14, 10 to the 20. So 35 equals to 500 minus 10t. Now simplify. 10t equals to 500 minus 35. 500 minus 35 divided by 10. T is 46.5 second. Find the total distance traveled by the car during the motion. This is the next question of question number 1. To find the total distance, we know that in velocity time graph, we need to find out the total area. So we know how to find the area of trapezium: half a plus b sum of parallel sides into distance between parallel sides. That means area of this whole shape, we can find out area of this whole shape. Total length is 60 and upper one is 50 minus 5, 45, and then this is 20. So total area of this shape is 60 plus 45, 60 plus 45 into 20 into half. We need to subtract it. This is t minus 30, 46.5 minus 30, it is 16.5, and then 50 minus 25. So this part is 25 and distance between this is 20 minus 6, that is 14. So 16.5 plus 25 into 14. Total area, distance of the car. So let me simplify now. This is 10. So 60 plus 45 into 10. 1050. Then let me simplify that one. 7 into 16.5 plus 25 closed. So this is minus 290.5. Now let me subtract 1050 minus 290.5. So this is 759.5 meter. So it covered total distance 759.5. 3600 kg is towing a trailer of mass 1200 kg along a straight horizontal road using a light horizontal rope. There is a resistance force 700 Newton for van and 300 Newton for trailer. The driving force exerted by the van is 2500 Newton. So let me draw the diagram first. Let me consider this is van. It is towing a trailer and it is driving force is 2500 Newton. These are connected by light inextensible string. There is a tension, and then resistive force is 700 Newton for van and 300 Newton for trailer. So let us consider that there is acceleration, that is A. Two things are 3600 kg and 1200 kg. Using the whole system as one unit, we can write 2500 minus 700 minus 300 equals to mass time acceleration. 200 plus 1200 plus 600 into acceleration. I'm resolving these things in this. We know that sum of forces equals to total forces equals to mass time acceleration. Now let me simplify to find out the acceleration. There is 2500 minus 700 minus 300. We are having 1500 equals to 1200 plus 3600. So this is 4800A. And if we simplify, we are having 1500 divided by 4800. 1500 divided by 4800. And if we simplify this, we are having 5 by 6. Sum of force equals to mass time acceleration. So tension then resistance equals to mass time acceleration is, now let me simplify, into 1200 plus 300. So it is 675. 675 Newton. Now driving force is removed and van driver applies a braking force in this direction and resistance force unchanged, string will be slack. So reduce, there is no force in that string. Now let me consider this braking force as F, and let us consider the acceleration is A for both the particles. So let us consider first van and resolving this direction. So minus F, sum of force equals to mass time acceleration, minus 700 equals to 3600 mass times acceleration. And in that same way, let me consider trailer. So resolving in the same direction, let me write 300, I mean minus 300 equals to mass time acceleration. So acceleration will be minus 300 divided by 1200. Now it is cancelled, so it will be 1 by 4. Acceleration will be minus 1 by 4. Let me use these values in equation number 1 to find the value of f into minus 1 by 4. Let me simplify. It will be 900, then minus 900 plus 700 equals to minus 200. So minus f equals to minus 200. So our answer f will be 200. This is the final answer. The diagram shows a semicircular track ABC 1.8 meter. This is the semicircular track. Its radius is 1.8 meter. The point A and C, this is the point A and C, are at the same horizontal level, and B is the bottom of the track. The section AB is smooth, I mean this part is smooth, and then section BC is this part is rough. A small block is released from rest A. We need to find out speed of that block at B is 6 meter per second. Gain in KE equals to loss in GPE. Gain in KE, I mean half mv square minus half mu square equals to mgh. So if we apply this formula directly, it will be half. Its mass is, let me keep it m, and v square, keep it same, and it's starting from rest, so half 0 square, mass is same, is 10. Then let me simplify all the m, so it is half v square equals to 18, v square equals to 36, and v equals to root over 36, that is 6 meter per second. The blocks comes to instantaneous rest for the first time at the height of 1.2 meter above the level of B. The work done against the resistance force during the motion of the block from B to this point is 4.5 B. I mean this same height. This is the track. This is the B lowest point, and let me check it. Okay, this is 1.8 meter. Now it's going above the level B, 1.2 meter. Let's see, this is the height. The work done against the resistance when it's going up, since there is a friction, resistive force for the work done by resistive force is 4.5 joule. Okay, we know the formula that work energy is total work done equals to increase in KE and increase in GPE. So let me write work done by any other force is 0, then work done by resistive force is minus 4.5. This is total work done, and increase in kinetic energy, that is half mv square minus half mu square. So half mv square is 0 because in maximum the velocity is 0. minus half mu square, I mean 6 square, since starting from here, so initial speed is 0, plus increase in potential energy, that is mgh. M G is 10, H is 1.2, since it's going up for 1.2 meters. So 4.5 joule equals to minus half into m into 36 plus 12 m. So I mean 18 to the 36, 4.5 minus 18m plus 12m. I mean 4.5 equals to minus 6m. So this is cancelled, and if we divide 4.5 divided by 6, we are having 0.75 kg. You have seen that in question number 1. This is taken from velocity time graph. Third one, you need to have sound knowledge regarding work energy principle. And if you go through the rest of the papers, you should have sound knowledge regarding resolving forces, inclined plane, connected pulleys, all these things. So practice is necessary for these things. A cyclist start from rest from a point A and travels along a straight road AB, and it's coming to rest B. Then S indicates that displacement. There's an equation given. You need to find out the distance A to B is 250. This is an important clue, that is at B the cyclist is at rest. That means ds dt equals to 0. So let me differentiate. S equals to 0.00475 t square minus t cube. ds dt equals to 0.00475 times 2 into t, 2 minus 1, 1, minus t cube, that is 3t, 3 minus 1, that is 2. At rest, ds dt equals to 0. So let me write here 0.00475 times 2, that is 150 t minus 3t square equals to 0. So this cannot be 0, so let me cancel, and t is common, 3t is common, so we can find 50 minus t equals to 0. T cannot be 0, so t can be 0 or t can be 50. At rest time is 50 seconds. Since we are finding out distance, let me substitute this t in s. 0.00475 into 50 squared minus 50 cube. Now it is necessary to use calculators. 0.005 sorry 4 0.004 75 into 50 square minus 50 cube. So it is 250. B, we need to find out maximum velocity of the cyclist. For maximum velocity, we know that for maximum velocity we need to find dv dt equals to 0. Then we need to find the value of t. So let me differentiate ds dt. d2 s by dt square, this is acceleration, equals to 0.004, then 150 minus 60. To find maximum velocity, we need to write acceleration equals to 0, then 0.004, 150 minus 60 equals to 0. 0.004 cannot be 0, so divide both sides by 0.004. So 150 equals to 60 and t equals to 150 divided by 6. If we simplify, we are having t equals to 150 divided by 6. So this is 25 seconds. So let me use these values to find velocity. Velocity is 0.004, then 150t, then minus 60, then minus 3t square. 0.004, 150 into 25 minus 3 into 25 square. Let us simplify. 0.004, 150 into 25 minus 3 into 25 square. So total, it is 7.5. Maximum velocity is 7.5 meter per second. A railway engine of mass 75,000 kg is moving up a straight hill inclined at an angle alpha to the horizontal and sin alpha equals 0.01. Engine is traveling at constant speed. We know that constant speed means zero acceleration. Its speed is 30 meter per second. Engine is working at 960 kilowatt. Its power is 960 kilowatt, and it's resisting. Constant force resisting the motion of the engine. We need to find out that resistance. Convert this power into watt. 960 kilowatt, then we can convert it. If I multiply it by 1000, it will be in watt. 1 kilowatt equals to 1000 watt. So 960 40 watt, and we know that power equals to work done by time, and work done equals to force multiplied by distance. So that means force into velocity. So work done, power is 960,000 960,000 equals to force into, here velocity is 30, so divide by 3, 3 is a 9, 3 is a 6, so F equals to 32,000 Newton. This is the driving force. Let me consider this as driving force. Now let me draw the diagram. This is the inclined plane and the angle is alpha, and this is the railway engine, and it is 70,000 kg, 7500 g, resolving this direction. So this is 7500 g sin alpha, and this side will be 75,000 g cos alpha, and this there will be driving force, and there is the resistive force, RF for resistive force, and there will be normal reaction. Now since this is constant speed, so acceleration will be 0. Now if I resolve in the direction of inclined plane, driving force minus resistive force minus 75000 g sin alpha equals to mass time acceleration. I mean 75000 into acceleration. Here acceleration is 0. Driving force is 32,000 minus resistive force minus 7540 into sin alpha is 1 by 0.01 equals to 0. Now let me simplify. 32,000 minus 750,000 into 0.01, so it is becoming 24,500. So minus RF equals to minus 24,500. Now if I simplify, resistive force equals to 0 Newton. Now this is the resistive force. Let's go for question B. The engine comes to the section of track which is horizontal. At the start of the section, the engine is traveling at 30 meters per second. Now its power is reduced power is 900 kilowatt. So it is becoming into 1,900,000 watt. So it worked for 60 seconds. So power equals to work done, I mean by time. So power is 900,000 divided by work done by 60. So work done equals to 54 123 joule. Resistance force, that is 46,500 kilojoule. That means 46,500 into 1000 joule. So it is becoming 46,500 and 3 zeros. The speed of the engine at the end of the 60 seconds. So we know from work energy equation, work done equals to, since it is going horizontal, change in kinetic energy, increase in kinetic energy. So work done by driving force minus work done by resistive force equals to increase in kinetic energy. That means half m is here 75,000 v square minus 75,000, I mean into u square. Initial speed is 30 square. So let us simplify to find out the correct answer, though the working you must do. So let me write it clearly again. 4650 equals to 75 by 2 v square minus 75 by 2 into 900 54000 minus 46500 plus 900, and then multiply it by 2, multiply it by 2, 82500 75 v square, 82500 divided by 75, then root over answer. So it is 33.2 meter per second. A block of mass 5 kg is held in equilibrium. This is the block, it's in equilibrium. It's by two string. There is one string, another string is here, and then there is x Newton force horizontal. This angle 60 degree, and with this force, that force, and x Newton, the object is in equilibrium. We need to find out the tension in the lowest string. This resolve all the forces in horizontal direction. So this will be, let me consider this as T2 and this as T1. Our target is to find out T1. So this is T1, this is 60, so this triangle, equilateral triangle. So this one will be T1 cos 30, and this is T2 cos 30, and this side is T1 sin 30, and this side is T2 sin 30. Now let me resolve since it is in equilibrium, acceleration will be 0, net force equals to mass time acceleration. So x is 100 minus T1 cos 30 minus T2 cos 30 equals to, mass time acceleration is 0, so it is 0. So minus T1 cos 30 is root 3 by 2, T2 cos 30 is root 3 by 2 equals to minus 100, multiply by 2, so T1 root 3 minus T2 root 3 equals to 200, multiply by minus 2, so T1 plus T2 equals to 200 divided by root over 3. And now resolve in vertical direction. So T2, there is another force, this is 50, 5g, so this is 50. T2 sin 30 minus T1 sin 30 minus 50 equals to 0. Let me take 50 in another side. Minus T1 by 2, sin theta is half, sin 30 is half, plus T2 by 2, then 50, multiply by 2 equals to 100. Now let us 1 and 2, 1 and 2. So 2T1 equals to 200 by root over 3 minus 100. So T1 equals to half 200 by root over 3 minus 100. Now let me use the calculator to find out, simplify this one. 0.5, 200 divided by root over 3 minus 100. So it is becoming T1 is 7.74 Newton. Let us draw the same diagram again. Find the least value of x for which the block remains in equilibrium in the position. So let me consider this as block. To make this block equilibrium, we can apply this force, upward tension, and then we can apply another force here, x Newton, That's enough to make the things equilibrium. And there is 50 Newton force. So resolving, this is 60, we can consider it as T2, and this is 30 degrees. So T2 cos 30, I mean adjacent to the side and opposite to the side, T2 sin 30. So let us resolve this in the direction of x. Since it is in equilibrium, acceleration will be 0 equals to mass time acceleration. So then resolving upper side, T2 sin 30 minus 50 equals to 0, mass time acceleration is 0, T2 equals to 100, T2 equals to 100. Let me substitute this 100 here, cos 30. So let me use calculator. 100 minus 100 into root 3 by 2. So this is 50, that means x equals to 50 root 3. So to keep it equilibrium, we will need it is 6.6 Newton force. Let us see question 7. Particle P and Q have mass mkg. P and Q have mass mkg and 2 mkg. This is P mkg, this is 2 mkg. The particles are initially held at rest 6.4 meter apart. That means these two particles 6.4 meter apart on the same line of greater slope, rough plane. So your plane is rough, that is there is a friction. Inclined at an angle alpha to the horizontal, where sin alpha is 0.8. I mean this alpha is 0. Sin alpha is 0.8. Particle P is released from rest and slide down. It's going downward direction. The line of greatest, simultaneously Q is projected. I mean Q is going upward direction. Obviously there is a speed given, and coefficient of friction between each particle in the plane is 0.6. Our target is to find out the acceleration of Q, that is minus 11.6 meter per second. We need to prove that. To find out the acceleration for Q, let me redraw the diagram again. This is, I mean normal reaction is, let me consider here R for Q, and this is 2 mg, and resolve in the direction of, I mean in the parallel to inclined plane and perpendicular to inclined plane. Since this is alpha, this must also be alpha. So 2 mg cos alpha, 2 mg sin alpha. And since it's going up with the speed, so there will be friction 0.6 RQ. Let us resolve perpendicular to the inclined plane. RQ equals to 2 mg cos alpha. There is given sin alpha equals to 0.8. Let me draw a right angle. This is 90 degree. So sin alpha is 8 by 10. So 8 is, this is alpha, this is 8, so it is opposite, and according to Pythagoras, so this will be 6. So cos alpha will be 6 by 10 adjacent by hypotenuse. So let me substitute here 2m into 10 into 6 by 10. Now it will be 12m. Now let me resolve in the direction of motion. Minus 0.6 r minus 2 mg sin alpha equals to mass time acceleration. Let me write here 0.6 into 12m minus 2mg 8 by 10 equals to 2m times acceleration. Let me consider m, then g 10 cancelled. This is 7.2, 6 12 are minus 8 to the 16 equals to 2a. Now let me use calculator. Minus 7.2 minus 16 divided by 2. So acceleration is minus 11.6. Therefore, acceleration is minus 11.6. So before starting this question paper, you should have sound knowledge regarding all the topics, all the concepts from your mechanics papers. Then you should have practice knowledge from your previous papers, I mean past papers. Then you can start this paper successfully. Speed of the combined particle immediately after the impact. Let us first find out what is the speed of P after t equals to 0.982, I mean before the collision. That means V equals to ut, V equals to u plus at. That means u is 0, a is 4.4 times 0.982, and if we simplify 4.4 into 0.982, so it is becoming 4.3208. Now since q is after maximum traveling, it's going downward, so v will be u plus at, same thing, 0 plus a is 4.4, but time will be reduced, so 0.982 minus 25 by 29. Now let me simplify this. 4.4 0.982 minus 25 divided by 29. It is becoming 5.5277. 0.5277. Now we know that the conservation of momentum m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. Now we can write, since it's going in same direction, so m into 4.3208 plus 2m into 0.5277 equals to, after collage, m plus 2m, that is both the masses together, then the velocity is, I have considered v. So m all are cancelled. Now simplify. 4.3208 plus 2 into 0.5277 divided by 3. So our answer is becoming 1.79. So v equals to 1.79 meter per second. So thank you very much and keep watching. I hope I can give you the best videos. Regarding B, we have already seen that q is going in upward direction with acceleration minus 11.6. Now, and m is going downward with acceleration a. Let me consider it a. Now let's see, q is going upward to go maximum distance, I mean to cover maximum distance. What is the time it's needed. Let me find it out. We know that for Q at max V goes to 0. So we can write V goes to U plus AT. V is 0 since Q is starting with speed 10 meter per second and its acceleration is 11.6. Let me find out time. Let me consider this capital T. So T equals to 10 by 11.6, that means 100 by 11.6, and if we simplify 425 and it will be, that means time it's taking time 25 by 29 seconds. In this time, what is the distance? Q is the particle Q is going. So let me find out that. So as Q equals to ut plus half at square. If we substitute 10 times 25 by 29 plus half into minus 11.6 into 25 by 29 squared, 10 into 25 over 29 plus 0.5 into minus 11.6 into 25 over 29 whole square. So total distance it's covering is 125 by 29, or approximately it is 4.3103 meter. What distance P is covering in that given time? For this reason, we need to find out acceleration for P. So its mass is m, so it's mg, and since it's going down, mu r will be in upward direction, r is perpendicular. So let me resolve. This is mg sin alpha and this is mg cos alpha. If we simplify, r will be mg cos alpha, and its acceleration will be in downward direction. So if we resolve in downward direction, so mg sin alpha minus 0.6, friction is 0.6, r is mg cos alpha equals to mass time acceleration. Let me remove m from all the sides. Sin alpha equals to, we have already got sin alpha equals to 8 by 10 and cos alpha equals to 6 by 10. So let me substitute it here. 8 by 10, 0.6 into 10 into 6 by 10 equals to a. And if we simplify, 8 minus 3.6 equals to a. So if we subtract, acceleration will be 4.4 meter per second square. Let me find out in that time, when Q covers maximum distance 4.310, in that time what distance P is traveling. So SP equals to ut plus half at square. It's starting from rest, so u is 0, t is given, so this part will be 0. Half, its acceleration is 4.4 and time is 25 by 29 squared. That means it's traveling a distance of 0.5 into 4.4 into 25 over 29 whole square. So its distance is now becoming 1375841. In decimal it is becoming 1.635. And if we add this two distance 4.3103 with this one, its traveling total distance 103. So its total distance is becoming now 5.945. That means q is, when q is going upward 4.310 meter per meter, that time q is going down up to 1.635 meter. After completing q 4.310 meter, it's going downward direction, and same time p is also going downward direction, and where they are meeting. Now let us find out the total distance in t seconds by p is sp equals to ut plus half at square. That means 1 by 2 4.4 into t square and 2.2 t square. This point, that time displacement of q is, it's coming up and going back. That is, this is the displacement. This is the displacement for q. As q equals to 4.310 minus 0 times t minus 25 by 29 plus half into 4.4 into t minus 25 by 29 whole square. So now total distance is becoming sp plus sq equals to sp plus sq equals to 6.4. So let me write here 22 t square plus 4.310 minus, that part will be 0, minus 2.2 t square minus 25 times 2 50 by 29 t plus 25 by 29 squared. Then let us simplify, equals to 6.4. So let us simplify 4.310 minus 2.2 t square plus 50 divided by 29 into 2.2. 100 110 divided by 29t. Then 25 by 29 equals to square it into 2.2. It is becoming 1375 minus 1375 divided by 841 equals to 6.4. This is cancelled. 6.4 minus 4.310 plus 1375 divided by 841 and then divided by 110 by 29. So your answer is becoming now t equals to 0.982 of the combined particle immediately after the impact. Let us first find out what is the speed of P after t equals to 0.982, I mean before the collision. That means V equals to ut, V equals to u plus at. That means u is 0, a is 4.4 times 0.982, and if we simply simplify 4.4 into 0.982, so it is becoming 4.3208. Now since q is after maximum traveling, it's going downward, so v will be u plus at, same thing, 0 plus a is 4.4, but time will be reduced, so 0.982 minus 25 by 29. Now let me simplify this. 4.4 0.982 minus 25 divided by 29. It is becoming 5.5277. 0.5277. Now we know that the conservation of momentum m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. Now we can write, since it's going in same direction, so m into 4.3208 plus 2m into 0.5277 equals to, after collage, m plus 2m, that is both the masses together, then the velocity is, I have considered v. So m all are cancelled. Now simplify. 4.3208 plus 2 into 0.5277 divided by 3. So our answer is becoming 1.79. So v equals to 1.79 meter per second. So thank you very much and keep watching. I hope I can give you the best videos. Thank you very much. Keep watching, and I'll upload P3 and statistics papers later on. And bye bye up to then.